They have it.
Does antimony precede mercury, possibly?
Antimony is very similar to mercury in the
Do
way
you have
it
to
behaves.
get it first before you get the mercury?
No, no. Antimony is just as bad as mercury, and it comes out with the same, usually with the same measures that we use for mercury. Antimony comes out. In fact, in homeopathy, homeopathic antimony is used to detox mercury. The law of similars. They're the most similar in their behavior. They're called the galenics, the way it moves through the tissues. Yeah. Okay, so let's look now at, we want to shift now to the molecular pumps, at the processes that the body has to get rid of mercury. And the first thing that we have to talk about here is genetics. Yeah, so the ability to detoxify has much to do where your ancestry is from. Yeah? If your ancestry lived close to Pompeii in Italy, where you had this huge volcano eruption a couple of thousand years ago, and the earth is completely contaminated with mercury and bismuth and arsenic and other things, and your ancestry grew up there, it has upregulated those genes that upregulate your enzymes that are responsible for detoxification. People that grew up historically in very toxic areas have they're more prepared for this time than people that grew up in healthy agricultural areas that have been living peacefully for thousands of years in some kind of remote mountain region with clean water and clean air and clean food. And those people weren't exposed to anything, and so their genes had no reason to focus their energy on the production of detoxification enzymes that they never need. And 200 years of making the world toxic has not been enough for us to mutate, so we developed those enzymes. We know that some enzymes can be upregulated simply by drinking alcohol and smoking and boozing and taking drugs, or so you upregulate some of the detoxification enzymes. That means that their activity increases and their presence, the amount of them increases. But to truly change the genes that code for that, when you have an absent gene for glutathione, it simply means that on both sides of your ancestry there was no need for a lot of glutathione because you weren't exposed to a lot of toxins. And so what we're looking at really, and this is where you don't have the story with the canary in the coal mine quite right.
Okay, good.
Yeah, so I want to use the metaphor of the canary bird in the coal mine. Coal miners all over the world used a very simple detection device if there's toxic gases in the air. Yeah, and remember that mercury vapor is odorless, tasteless, and invisible. And that means, if a miner, for example, is exposed to huge amounts of mercury vapors, which occur naturally in the earth where you're digging for coal, the miner would long have exceeded the lethal levels before he ever knows it. And however, the birds, and especially the canary, is especially sensitive to toxic gases. And so what they did, in a normal bird cage, each group of miners, in Germany was every 10 miners had one bird cage with them down there, and they feed the bird while they're down there, and they treat it nicely, and once the bird falls over sideways and croaks on the spot, they know it's time to get the hell out of there. Yeah, this is the canary in the coal mine. It was used all over the world as a principle to assure the safety of the miners. Now, what we're saying in autism is that the autistic children are the canaries in the coal mines. They're the kids that are more sensitive to the toxins than other kids. And they're the ones that are croaking in front of our eyes to give us a signal, it's time to get out of here. Except we don't really know where to go from here. Mars, Venus, they don't seem to be that hospitable. And so another way of putting this is that the epitome of autism is an early warning sign that things are going really badly wrong. And I stick with my statistic that 20 years ago autism incidence was over 1 in 100,000, and a couple of years ago, when the statistic was redone, it was 1 in 166. This is already a couple of years old, so it's a lot more than that now. We're suspecting it's less than 1 in 100. Oh, sorry, more than 1 in 100 now that has it. And if you take the spectrum, it's 1 in 6 children a few years ago that has a learning disability. You know, if we take the learning disability as the mild end of the play out of the toxicity, and the 1 in 166 at the most extreme case, we can say that there is strongly clinically detectable effects already in 1 in 6 kids. And this was a few years ago. And statistics now suggesting in American schools, you know, like when they look at how many kids are on psychiatric drugs and so forth, it looks more like it's 1 in 2 or 1 in 3 kids is affected in some measurable clinical way. Yeah. And yes, if you take this as the spectrum, and when I use autistic spectrum disorder term, I mean the entire spectrum, where the mild brain deficiencies and the severe ones are just a measure of amplitude, but not of quality. It's still the same measures. These kids, I know when we treat a kid with a learning disability the same way we treat an autistic kid, they also get well. And therefore I know, and I may be the only person in the world that knows this, that the underlying causes for the mild learning disability are the same underlying causes as these ones are. It's just a matter of how much accumulation is there, what is the genetic makeup of the person, you know, how are their detox pumps working. You know, and the mild case, they either have lesser exposures or have better pump mechanisms to get rid of them. You know?
And wouldn't you not put on the spectrum, but put also part of this toxic model, like eczema and asthma and all the things that are wrong with kids these days? It's all coming from excessive toxicity.
Yeah, we call them the 4 A's: atopy, atopic allergy, autism, and asthma. You know, they're all in the same extension of the same spectrum, just slightly different genetics.
Different break in the chain.
Different place where they cannot detox, where the accumulation is of the toxins. And so
it might be helpful, Dr. Conrad, if you explain your spectrum. What's your autistic spectrum from the beginning to the end?
Yeah, I like to not do that, not to explain it, because I know this is a very contentious issue. You know, when I talk with neurologists, I need to stay strictly with the, what's that, DSM-4 or 5 or 6,
it's
whatever
4.
we have now, 4. It's still 4. And I think we should put that definition of autism in there in the book, just so to say, okay, this is a conventional medical diagnosis. And then I've been sort of following, like, over the last 20 years, the further and further refinement, you know, the Asperger's, Rett syndrome, you know, there's now like all these subtypes of autism, which I personally find ridiculous, because for me, the most important thing is it is a neurotoxic disorder. And depending on the genetic makeup and the other cofactors that we'll discuss, the electromagnetic field exposure, the food allergies, the psycho-emotional circumstances, the health of the home, the health of the, now we know from this last study, the county that you happen to live in. All these things kind of are pre-existing factors that shape how the neurotoxicity plays out in you. Yeah? The kind of birth you had, the craniosacral damage, the occlusion, you know, with the lymph drainage, the strep infection you get from your little brother. All these things are cofactors that then shape the picture of what you have. And yet, if I would get lost in a definition of the different syndromes, also, I would buy into the model suggesting that they're all different. Yeah. What I'm looking at is that I'm very, very clear that all these illnesses are the same.
And two that would definitely be in there: ADD, attention deficit disorder, and ADHD, attention deficit hyperactive disorder.
All of these things. I see no difference in what we have to do to resolve these cases. We do the exact same thing, and kids get well when we follow that.
Understood.
Okay.
So, when we look at the genetic makeup, so in the last few years we did a lot of genetic testing on the kids, and we find very, very common defects. We find defects in the genes, in the P450 pathway in the liver. That's a series of many hundred enzymes, how a toxic substance is broken down in the liver before it can be excreted. And it's funny, you should think that the body can excrete toxins. No, it has to first make them non-toxic before it can be excreted.
Right.
Which is interesting to me. It basically means God has made us a processing plant for toxins. We actually detoxify the earth. We take a completely toxic substance in, and it goes through our machinery and comes out fairly non-toxic. That's the P450 pathway. It's miraculous. And so we find in virtually all the kids that I've tested several polymorphisms of genes in this pathway.
Polymorphism is a double.
No, polymorphism is it means that the shape of the gene is not the normal shape.
Okay.
It has some multiple other shapes than the normal shape.
So when they're talking about like a single and a double allele, are they just applying a standard to that picture?
Yeah. No, you have for each enzyme that your body makes, you have the blueprint for that from your dad and one from your mom. And each one of these is called an allele. And you can have a polymorphism on one allele only or on both alleles. When you have only one allele dysfunctional and one is functional, you can, from the currently available testing, you cannot say that your body is making the wrong enzyme. If both alleles have an abnormal shape, you know that the enzyme that they're making is wrong.
It's a heterogeneous mutation.
Yeah, both of them are bad.
If one, it's a homozygous.
If one is abnormal, you cannot really say for sure, because it could be that the good one is the one that is used as a blueprint to make the genes. However, it is suggested the more you have, of this polymorphism, even if it's only one of the two alleles, the more you can assume that this pathway is defunct, it's not functioning very well. Yeah?
Okay.
It's sort of the current interpretation that we're aware of, and there maybe other shades and gradations. The worst one is when the gene is missing, when both of them are simply not there. That means there's a complete break in the chain of, taking a toxin and whatever, taking a methyl group off, and then taking an acetyl group off, and taking a nitrogen off, and taking a hydrogen off. So this is how it goes. It's sort of like, you like if you make two rows of people and you have one person go through. We used to play that as a party game, and each person in the row takes like a little piece of clothing of the person moving through. And by the time you come out of the end, some people still had their underwear on and some didn't. And the more is missing in these steps, the more is still there, the more toxic the substance is still at the end when it comes out, and the least likely it is to actually make it all the way out, because if it's still a neurotoxin functionally when it comes out, it will seek the next nerve on the way down to attach itself to. But if it has lost its neurotoxic capabilities, if it comes out at the end of this pathway, it can safely go through the bile ducts, which are lined with nerves. It can safely go through the small intestine, which are lined with nerves, without reattaching itself. But if it's coming out and still has some of its neurotoxic properties, it will attach to the next nerve and make it circle through the whole system again. So that's the P450 pathway in the liver. Virtually all the kids that we've had several polymorphisms in that pathway.